All right, welcome to our last computer science unit. This one is something that is on this year's EP test, and the topic is sorting. Right? In the book of chapter 14, it's kind of our last chapter, and it's a little bit different where basically we're going to talk about how you sort numbers, like a set of numbers, and there's three different algorithms that are on the AP test. In real life, there's actually tons of different sorting algorithms. You can look them up. There's probably like 100 of them. Some of them are actually quite genius. But the test just includes three. And one thing that's different is you don't actually have to program any of the algorithms. You more or less have to like maybe understand how they work and analyze the code related to the algorithms, right? So here we're going to develop algorithms to sort numbers. And we're going to talk about our first sort, which is called selection sort. So there'll be three on the AP test, and today's will be about the selection sort. Okay, so just a little bit of vocab here for you is here's an array, right? So this chapter we're going to be doing a lot with arrays because you're going to have like an unsorted, here's 5 ints, index 0 to 4, they're unsorted. And then we do a sorting algorithm, right? That's where our algorithms will put them in order from least to greatest. All right, so that's just a little vocab. Okay, so I do have a good activity here that I would like you to try. If you can get out a set of cards and just sort them from least to greatest as fast as you can, with aces being low. I was going to give candy and stuff in school, but basically see if you can come up with a strategy. This is going to be our algorithm of how you would actually do this. Like what would be the sort of the fastest way to do this? And there's lots of different right ways. So either get out a deck and try it, or just think through how would you do this? Like what would be if you want to do this as fast as you could, right? And you're competing against the other groups. What algorithm would you use? Okay, pause the video if you haven't already paused it, and then I'll come back and talk through a little bit of it. Okay, so just some general strategies. One might be to just go through and find all the aces, then find all the twos, then find all the threes, right? That's actually similar to what we're doing today called selection sort. We just kind of select the lowest ones first, put them in their place, and then move on from there. In the past years, I've had kids like split the deck in half, right, and then have the two students kind of sort them individually and then merge those back two together. That's actually one of the ones that's on the AP test called merge sort. Um, I'm trying to think what else. Oh, I've had people put all the like aces together, all the make like 13 piles, one for each value, aces up to jack, queen, king, and then just pick the piles from there. That's actually a really good way to do it. That would actually probably win a competition like that. And that's a thing called like a bucket sort, which in real life is actually incredibly fast way to sort. Um, so lots of different ways to do this, but that represents why there's a lot of different sorting algorithms. Okay, and so this is important, right? And so like I want to just talk, well, why did I put this in and why this matters? I will do this more later, but why this is important is speed is important. Okay, so I did this earlier. I searched for bumpkin, right? And so to me this is incredible that Google takes a half a second, can search the entire internet and get all these millions of results in just half a second. Okay, and so that's sort of what made Google famous was their search, and the reason is it's so fast, and it comes back so fast and pretty accurate, right? So obviously in the world of computer, being able to be quick is important. Think of your phone. If you clicked on something and it was slow to respond, your program's probably not going to be super popular, right? Just for fun too, if you want to look up the images of Bumpkin. I was looking for Mitchell here. I didn't see any, but yeah, there's if you don't have an idea of what Bumpkin is, here's some images for you. All right, back to the story at hand. Okay, so for me to just mimic what selection sort looks like, that's the goal for today, right? There's a lot of them. We're going to talk about selection sort, right? And so selection sort um, sort of has two indexes, all right? And it's gonna loop through them. You don't have to do this activity up here. We're just gonna kind of go through what the code does. So you just loop through and select the lowest spot. So basically what it looks like is it says, okay, I want to start here and say I know that this needs to be the lowest card. So it just goes through and says finds the minimum. Oh, here it is, right? And so then it's going to swap these two, right? And to do that, it's going to need like a temp variable I think we talked about swapping before, where you can't just flip-flop them, because if you overwrite, like if I overwrite the 3 here, right, put it here, and then try and put the 9 back, well, I've overwritten the 9, and it's not there, right? So what you actually have to do is kind of make like a temp variable, move the 9 down here, put the 3 here, and then swap the 9 back there. Okay, and then what selection sort says is it says, okay, the first spot is sorted. So now I'm just going to go through and say, okay, what's the minimum of the remaining ones? Right, so it goes, it says, oh, 7's the min. So now it does that swap deal where we put this one as temp, move the 7 in place, and then put the queen where the 7 was. Now the first 2 spots are sorted, moves over, and repeats this process. So it just says, okay, find the min here, 9's the min. So then, actually I could label this, maybe just do a little m for min or something like that. Right, and min is going to be the index of the minimum. So then it says, okay, I'm going to move that one down temporarily, move this in place, and then put that one there. Okay, and then it just keeps going, blah, 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 blah. So now it's going to switch in the 10. Okay, and then it goes one more time, and then it's going to flip-flop these. I should do it the way it does it, actually. Moves this one down, puts this one in place, and then slides that one back. Okay, and now you can see you have them in order. And so we don't actually need to do the last one. By default, that one is already in sorted position. Okay, so all I want to do now is walk through like the code. You don't have to write the code, but you have to understand it. So I'm going to just kind of do the same process, but I'm going to show you like what the code starts to look like. Right? If you want a good challenge to try and code this yourself, that'd be a really good challenge, right? But yeah, at any rate, so you've got 2 loops actually. So you have one loop that's this star that just represents the position we're trying to find the min for, and it moves down and it goes from 0 up to 1 less than the last index, because the last one by default is sorted. All right, and then your other one actually starts to the right of the star, and it's finding the min of all of the cards. So it actually starts by comparing star with the min, right, to determine what is the min between those two, because this could already be in sorted position potentially. So it just kind of says, okay, what's the min of these two, right? And so it'll keep going, keep going, keep going. It does have to go all the way through. Once it finds the min, then it moves this one down to the temp variable, puts this one in place. Ooh, I did that wrong. Sorry. It finds it for the first spot, moves that one down, throws this one there, and then swaps this one back. All right, and then it resets everything. So this moves over one, and then this second index always starts one to the right, and just compares these first two and says which is the smaller. And then it goes keeps smaller, keeps track of the min, and it does find the min here, but it has to keep looking, right? So it does keep going down the line here and checking to see, even though we can see that it's the min, it will actually cycle through and keep going and then say, okay, we found the min right here, and so that's the one we need to swap. So then again, it moves this one down, puts this one in place, okay, and then this guy moves over again. So sorry for the lengthy explanation there, but you have 2 loops, and then you find the min and then swap it into position and then move the outside counter over one. Okay. So, sorry. Just want to say again, what is on the AP test for this chapter is there's 3 different sorting algorithms, and today is just called selection sort. All right, and we'll also talk about like which one's the best and the fastest, but generally you just have to know how to like interpret what's happening with these. All right, so just to help us understand selection a little bit more, here's the Mr. Westall version of it. You search the list and find the smallest value, put that value in position 0. Search the remaining positions, one at the end of the list, and find the smallest value in the remaining numbers. Put the second smallest in position 1, and then you just kind of repeat that process. Right, so this is maybe not the greatest definition, but that's what homework's going to be, is to have you try and type this up in your own words or explain selection sort in your own words. right? One more thing I want to do to try and help you is I have this thing that will hopefully help you visualize what's going on with selection sort. So we can see we have an unsorted set of ints, and see if I can get this to work here. From the beginning, oh, it's not going to work. Sorry. All right, I'm going to try this again. See if I can get this stupid selection sort to go here. Ugh, sorry. Why is this not working? Okay, play, selection sort, play. All right. I am not sure why I can't get this to run. Sort. Oh, maybe here if I go. Okay. So here now it's finally running for you. So as you can see, this says we're on position 1, and it's just going to go through and find the min. I'll speed it up here a little bit for you. All right, and the key is it doesn't, oh, it did find the min. All right, so it's just marking it as the min right now, right? And we don't know it's the min until we go all the way to the end. And then it swaps it. Okay, and then it, now we're looking at the second one. Considers the first thing sorted, and now it's just going to go through. Maybe I'll speed it up again a little bit. Right? And again, it has to go all the way to the end before it knows it found the min, right? We can see that, but it doesn't know that, so it has to go all the way to the end, right? So same thing. Now the first two are sorted, and it's just going to go through and figure out where the next min is. It's marking it in red there. Boom, swap it. Right now, again, 5 is the next one, but it has to go all the way through and look to see, hey, is there one less than 5? No, there's not. So boom, stops. Right. And some you could already imagine ways to make this more efficient. Like if this value here was a 5, you'd know it'd have to be the min, right? Because you already searched through. But at any rate, it'll just keep going and going until it's completely sorted. And so I'll see if I can do it in speed mode here, but hopefully you got the idea at this point. And I think this is a really good site for visualizing it. It's finding the min, swapping it into the next position. It's selecting the min. That's why it's called selection.